All right, today we are doing a deep dive into a very specific piece of hardware, the NTI EDCLM-6 DC line monitor.
Mm,
It's a $225 component, which, seems small, but it's apparently central to maintaining power stability in some really critical infrastructure.
exactly. Our mission here is to get a quick but, thorough understanding of this kind of specialized sensing equipment. The E-DCLM-6 is essentially the dedicated messenger for your DC power as health.
A messenger.
It takes readings, reports voltage and current back to the main ENVIROMUX units. Think of it as the super accurate triage nurse for your battery banks.
I like that framing. Okay, so let's start with voltage. It's got 6 terminals, covers a range from -60 to +60 volts DC.
Right.
But the number that really jumps out at me is the resolution VORT12 VDC. I mean, why is that kind of surgical precision so important in, say, a server environment?
Well, it's not just a number. It's about getting ahead of the problem. It's about genuinely predictive maintenance.
Ah,
A battery or a power supply, it doesn't typically just fail instantly. It drifts as it degrades.
right, it's a slow process.
It is. And if you can spot a drift of just 0.12 volts, you're catching the absolute precursor to a total failure.
Days or weeks ahead, maybe.
Potentially. It moves you from reactive alerting to proactive operational management.
That makes sense. But then we get to current monitoring, and this is where the spec sheet gets a bit, well, tricky for me.
Ah, yes. The transducers.
Right. For current, it needs external Hall effect transducers. So for a $225 device, why is this, crucial part sold separately? Doesn't that make things complicated for the user?
That's a really critical question, and it gets into system design. The EDCLM-6, it provides this sophisticated interface, and it offers a 0.2% resolution on the data it gets.
Yeah.
But the measurement itself
Is outsourced.
is outsourced, exactly. A Hall effect transducer measures current indirectly by reading the magnetic field.
So it's non-contact.
Non-contact and highly flexible. So it gives you adaptability, but it means the accuracy, the range, the cost. It all depends on which external transducer you buy and attach to it.
So it's a great reporter, but you have to provide the source. Okay, let's talk scale. Standard CT5 cable, it says here, gets you up to 1,000 feet.
Which is already a pretty good distance, yeah.
But then you see this EFSC fiber converter extender.
And that changes the entire game.
Mm-hmm.
Completely changes the monitoring architecture.
We're talking 1.2 miles.
2 kilometers, yeah. You can stretch this monitoring point so far from the main ENVIROMUX unit. Think about remote edge computing sites.
All feeding back to one central hub. Wow.
Precisely.
That is impressive. But with remote sensing, you always have to ask about power. It says it's powered by the main unit, which sounds easy enough.
It sounds convenient, but there's a catch.
There's always a catch.
There is. The catch is consumption. This sensor draws 190 milliamps at 12 volts DC.
Okay, that's not nothing.
No. And if your RJ45 sensor ports can't supply that reliably, especially over a long cable run, well, you might need the optional power supply.
So it's something you absolutely have to account for in the design phase.
It's a critical operational caveat. It separates a successful installation from one that, unpredictably drops offline.
Got it. And just to round it out, the physical specs are pretty straightforward. It's a small box, TAA compliant, CE or OHS, all the usual stuff.
Right. So when you pull it all together, the EDCLM-6 is really a highly specialized electrical watchdog.
A watchdog. I like that.
Valued for its precision
Yeah.
and that, architectural flexibility, especially with the fiber.
So the big takeaway for you, the listener, is that this device is really a perfect lesson in systems integration. It shows how granular remote monitoring has become, right down to that tiny 0.12 volt detail. But it also shows how dependability is often, spread across multiple components.
And that segmentation raises an important final question, a final thought to leave you with.
Right.
How does requiring a separate Hall effect transducer, a component whose accuracy and range entirely define a core function, how does that change how you calculate the system's total cost of ownership and, maybe more critically, its long-term reliability? Something to mull over.